A brand new truck, $180,000. The latest technology, more sensors than a commercial airplane, broken down on the side of the highway, waiting for a mechanic with a laptop. 3 miles down the road, a 1998 Peterbilt, all scratched up with faded paint and 1.8 million miles on the clock. Still moving. No warning lights, no error codes, no laptop required. Just an engine that refuses to stop. And here's the question nobody in the trucking industry wants to answer. How does a truck built before Google ever existed outlast a machine worth more than most people's houses? It's not nostalgia. It's not stubbornness. It comes down to one engineering decision made in 2007 that quietly changed everything about how truck engines are built. And once you understand it, you'll never look at a new truck the same way again. To understand what changed in 2007, you first need to understand what existed before it. 3 engines, built during the golden age of trucking. The Cummins N14, introduced in 1994, a mechanical engine in the purest sense. No complex emission systems, no software dependencies, just fuel, air, and combustion, done with brutal precision. Trucks with over 2 million miles on an original N14 exist today, and most of them are still working. Next is the Detroit 60 series, so reliable that the U.S. military used it. Fleet operators who own pre-2007 trucks hold on to them specifically because of this engine. When one comes up for sale, it sells fast. And the Caterpillar 3406E. This is the last Cat engine that was ever built for highway trucks. Not because it failed, not because it wore out, but because Caterpillar made a business decision and walked away from the market entirely. Used versions sell for more today than they did a decade ago. These weren't just good engines. They were simple engines, mechanical systems that any experienced driver could understand, that any independent mechanic could diagnose, that could be rebuilt in a roadside shop with standard tools. Then came 2007. New emissions regulations, introduced by the EPA, required truck manufacturers to dramatically reduce the pollutants coming out of their exhaust systems. The goal was clean air, and that goal was legitimate, don't get me wrong. But to meet the new standards, engineers had to add systems inside and around the engine that had never been built before. And that's when the engine stopped being something a driver could fix with his own hands and became something only a computer could understand. On a truck that runs 150,000 miles a year, hauling heavy loads across mountain grades and desert highways. And then consider this. A modern engine overhaul at 400,000 miles, which is when many new trucks begin showing serious wear, costs upwards of $90,000. A Cummins N14 overhaul costs around $15,000. And after that overhaul, it runs for another 800,000 miles. This is not a hypothetical. This is what owner-operators are living every day. Take the story of one independent driver who brought a brand new Freightliner Cascadia in 2019. Within 12 months, 3 separate DPF failures, each one taking the truck off the road for days, each one costing thousands in parts, labor, and lost contracts. After the 3rd failure, he sold it. Then he bought a 2003 Kenworth T800 with a pre-emission N14 under the hood. 900,000 miles on the clock. He bought it for a fraction of what he paid for the Cascadia. 3 years later, he's still running it. No DPF, no EGR, no DEF. When something breaks, he fixes it himself in his own shop with tools he already owns. Because that's what the engine was designed to allow. And that is exactly what modern engines are designed to prevent. Here's where it gets complicated. Because modern trucks are not bad trucks. Let me be clear about that. A new Peterbilt 579, a Volvo VNL, a Kenworth T680, these are extraordinary machines, safer than anything built in the 1990s. They're more aerodynamic, they have better fuel economy, they're more comfortable for the driver spending 300 nights a year behind the wheel. For a large fleet, 50 trucks, 100 trucks with dedicated mechanics, software subscriptions, and dealership service contracts, modern trucks make complete sense. The technology works when it's properly maintained by people with the right tools and the right training, but that's exactly the problem. Because the trucking industry isn't built on large fleets, it's built on owner-operators, single truck owners, small family businesses, independent drivers who maintain their own equipment, manage their own contracts, and absorb every unexpected cost out of their own pocket. And for that person, a truck they cannot diagnose without a $10,000 software subscription is not an asset, it's a liability. After 2007, and even more so after 2017, repairing your own truck became increasingly difficult. Not because drivers got less skilled, but because manufacturers began locking engine diagnostics behind proprietary software. You can hear the problem, you can feel it, but you cannot read the fault code without a dealership tool. Which means every warning light sends you to a dealership. Every diagnostic session costs money. Every repair that used to take a weekend in your own shop now takes 2 weeks at a service center, if you're lucky enough to get an appointment. You're not just buying a truck anymore, you're buying a subscription to your own vehicle. And that changes everything about what ownership actually means. So here's the question that every owner-operator eventually asks themselves. What's the point of saving 2 miles per gallon if a single sensor failure costs you $15,000 and 2 weeks of income? The most expensive truck on the market can bankrupt a small operator faster than the cheapest one ever could, and that is not an opinion, it is a fact. That is the financial reality that is pushing thousands of independent drivers back towards trucks that were built before any of these systems existed. So now let's go back to those 3 engines, because they deserve more than just a mention. The Cummins N14 was introduced in 1994. Fully mechanical injection, no emissions hardware, no software required to run it, just a precisely engineered system of fuel and air that was designed from the ground up to last. Truckers who run N14s talk about them the way other people talk about family. Not because they're sentimental, because the engine has earned it. There are documented cases of N14s reaching 2 million miles on the original block. Not rebuilt, not replaced. The same engine that left the factory in the 1990s, still turning, still pulling, still working. When an N14 finally does need a rebuild, it'll cost you around $15,000. A skilled independent mechanic can do it. No proprietary software, no dealership required, just knowledge, tools, and time. And after that rebuild, it can run for another 800,000 miles. Then there's the Caterpillar 3406E. Cat stopped making highway truck engines in 2010. Not because the engine failed, not because the technology was outdated, but because meeting the incoming emission standards would have required compromising the one thing that made the 3406E legendary: its simplicity. So Cat walked away, and the market responded in a way nobody predicted. Used 3406E prices have increased every single year since production ended. Truckers actively search for low-mileage examples. Rebuilders specialize exclusively in this engine. A well-maintained 3406E today is worth more than it was the day Cat stopped building them. That doesn't happen with machines that people have forgotten about. That happens with machines people refuse to give up. And then the Detroit 60 series. An engine that was so dependable that the U.S. military trusted it in operational vehicles. Fleet operators who run pre-emissions trucks hold on to Detroit 60s the way investors hold on to gold. Not because nothing better exists on paper, but because nothing better exists in practice for the way they work and the conditions they work in. These three engines share one characteristic that no modern truck can ever replicate. They were built to be understood. Not by a software system, not by a dealership tech with a laptop, but by the one person behind the wheel, by the mechanic in the independent shop, by the owner-operator lying under his truck at midnight in a rest stop parking lot, fixing the problem himself and making his delivery on time. That principle, that a machine should serve the person using it and not the other way around, is what made these three engines legendary. And it's exactly what modern engine design, for all its brilliance, left behind. So here's what I want to know. If you had to choose right now, what truck would you trust your livelihood to? A brand new $180,000 machine full of technology that you cannot even touch without a laptop? Or a perfectly maintained classic, 2 million miles proven that you can fix yourself anywhere, anytime? Drop your answer in the comments below and tell me why. Because I have a feeling that the trucking community is going to be very divided on this one. If you learned something today, leave a like. It helps more people find this channel. And don't forget to subscribe, and I'll see you on the next road.